Now let's focus on the function notation. Remember, we're used to y value being our output, or y equals f of x. F of x is our function notation. So this reads y is the function of x. And remember, we don't always use y and x. We could have n being a function of t. We could have profit being a function of cost. We can also use, instead of f of x, if we're dealing with several different functions, we can also use g of x or h of x. All of these still represent function notations. Make yourself a note, does not mean multiply. Okay, so you have to look at the context. So on the left, we're considering people. We've got three people here, Alex, Missouri, and Beto. And then we have birthday months of March and April. So let's say that Alex has a birthday in March, Missouri has a birthday in April, and Beto also has a birthday in April. Since every person has one unique birthday month, then we can say that the person would be our X and the birthday month would be our output or our function. In other words, the birthday month is a function of the person. The birthday month depends on which person you're referring to. Does it work the other way around? Does the person depend on the birthday month? In other words, if I picked June, I said the birthday month is June, do only one person in the world have a birthday in June? No, a birthday month would not have a unique output. So we would say the person is not a function of the birthday month. So again, just remember that whatever input value you have, the output or function value has to be unique. So the birthday month is unique, so a unique function value of the person, but the person is not a unique function value of the birthday month. The output is a unique function value of the input. So when you're stating it, you're basically saying that the output is a function of the input. But again, it has to be unique, otherwise it's not a function. So let's work with some examples of the function value. If we're given the function f of x equals x squared minus 3x plus 5, they're wanting to find f of negative 4. So I like to write it directly underneath that given function value. And remember, this should equal our output value, which we can, again, use y just as generic. But notice that negative 4 just replaced the x inside the function notation. That's a hint. Everywhere there's an x, we're going to replace it with that negative 4. So this will give us a positive 16 plus 12 plus 5. So the function value of negative 4 is 33. Now, what does that mean? Written as a coordinate point, the point negative 4, 33 is on the graph of that equation. Number 5 is very important because what's the point of doing generic problems if you can't relate it to something in the real world? So if you're working in business or biology, or if you're doing some sort of research, we need to be able to interpret what we have. So if we have a function, n equals f of t gives the number of police officers. So let's kind of make ourselves a note that n, or f of t, is going to give us the number of police officers. I know it looks weird using the hashtag. I'm old school. Pound always meant number. So in a town, T years after 2000. So T itself represents number of years after the year 2000. So they're asking us, what does f of 5 equals 300 represent? So let's keep in mind, here's the original, f of t equals n, equals, so I can switch it. They're giving us f of 5 equals 300. So that means my n is 300. So think of it this way. My n is my 300 and my t is replaced with that 5. So my n is 300 and my t is 5. So let's figure out what that means. I have 300 police officers and the time or the year is 5 years after 2000. So that would be 2005. So how would we state that? In 2005, there were 300 police officers and they didn't give the name of the town. So we could say just in a town.